We are now going to solve rational equations. The equations with one or more rational expressions, what we need to do is, before solving, note the values the variable cannot be. So anytime a variable is in the denominator, you set the denominator equal to 0 and solve. Okay, 2. Make the fractions disappear by multiplying by the least common denominator. And then you're going to solve the remaining equation. And then make sure you exclude false answers, which to determine the false answers, that's why before solving we say x cannot be these values. Okay, so let's solve this one. Well, at first, x cannot equal 0. Now, the least common denominator, remember you write every single denominator down and leave out the factors that are the same. So 3x would be our least common denominator. We have a 3, we have an x. So we're going to multiply 3x by every single term. So x times 1 is x. We have minus 30 equals negative 9x. Add, and now you can solve like normal, like a normal equation. So this will be 10x equals 30. So x equals 3. That is an answer because it will not void our denominator. Three over 5 plus 7 over x plus 2. So x cannot equal negative 2 because if you plug negative 2 in for this, the denominator will be 0. 7 divided by 0 cannot happen. So the least common denominator, we have a 5 in this denominator. The next one we have x plus 2. So 5x plus 2, 5x plus 2, and 5x plus 2. Okay, and you'll get to the point where you will only multiply the numerator by whatever is missing in the denominator, especially when your LCD becomes lengthy. It's just a little shortcut. 2 times 5 is 10. I'll just change that to 10, and then we'll have to multiply that by x plus 2. It's x plus 37 and x plus 20. Negative 9x equals negative, 17? And then divide by negative 9. And that's not what I should be getting. Oh, oops, this, I see. Okay, stop. I found a mistake. I was supposed to multiply this by 3 because we have to multiply our numerator by what is remaining. I found a mistake. And that is a common mistake. So 3x plus 41 equals 10x plus 20. Okay, so common mistake there. Learn from my mistakes. That's why I make them. So move the 41 over, move the 10x over, and you get x equals 3, and that is a valid answer because it is not negative 2. This one will probably be the last one. It is a little more intense, but we need to factor. So factor, and you can see that x minus 2 is common among all of those denominators. And then we're missing x minus 5 on the other, so in order to make all of these the same, we need to multiply x minus 5 by these two. X cannot equal 2 and 5 if you plug 2 and 5 into some of these factors. Now, we're going to multiply every single term by the LCD. I'm not going to write that 3 times, so I'm going to look at the denominator. So this denominator will cancel this out, so I will multiply the numerator by the x minus 5. This one has both, or will cancel out both of these, so we will have a plus 1. And then this one, the x minus 5 will remain when we cancel these two out. And we are going to distribute that 6 through. X minus 4 equals 6x minus 30. Let's do some rearranging here. Negative 5x equals negative 26. And then divide by negative 5, so x equals 26 over 5, which does not which should not be excluded from our answer, so that should work. I'll show you a no solution, and sometimes you can shortcut these rational these rational equations by cross multiplying if the denominators are different. Since the denominators are the same, the LCD is x minus 3. X cannot equal 3 because if we plug that in, we get 0. So both of these denominators cancel that, so we will just be left with our numerators. Okay, so x minus 3, if we multiply by our LCD, they cancel. 2x plus 2 equals x plus 5. Get 3x equals 6. Now we'll get, oh my goodness. We'll get x equals 3. I knew there was a 3 somewhere. I was overthinking here. Okay, so x equals 3, but if we plug 3 in, we will get a 0 in the denominator, so we will have a no solution. That will conclude this video.